Most people think that symmetry is just about things looking neat and balanced, but it's far more complex and rich than that. Because symmetry isn't really about appearance, it's about the hidden rules that never seem to change. And when those rules break, entire universes can change with them. Is reality built from objects or from symmetries that survive change? Physics, Consciousness and Reality, Dickie Dredd and Nigel Adams. We are now on part 34 of the video series, still in chapter 4, Mathematics, Beauty and Limits. And today we will talk about section 31 in the book, Symmetry and the Shape of Laws. If there is one word that captures the elegance of maths and modern physics, it is symmetry. At first glance, symmetry might seem like nothing more than a matter of visual balance, the left side of a butterfly's wing matching the right, a snowflake repeating its pattern. But in physics, symmetry means much more. It is about the invariances of nature, the deep regularities that stay the same even when the details shift. And symmetry is a transformation that leaves something unchanged. Rotate a perfect circle and it looks the same. Reflect a square and the pattern remains. In physics, symmetries describe what does not alter when we change our point of view. If the laws of motion work the same on a Tuesday as on a Friday, that is a symmetry of time. If the equations work equally well in London or on the moon, that is a symmetry of space. Noether's theorem, one of the most beautiful results in mathematics, tells us that every symmetry corresponds to a conservation law. Invariance under time shift means energy is conserved. Invariance under spatial shifts mean momentum is conserved. Invariance under rotations means angular momentum is conserved. The great bookkeeping principles of physics, energy cannot be created or destroyed. Momentum is always accounted for. All arise from symmetry. The 20th century revealed that the particles and forces of nature are also governed by symmetries, and these are more abstract. The Standard Model is built around so-called gauge symmetries, mathematical transformations that shuffle fields in ways we cannot yet see yet leave the physics unchanged. These symmetries dictate the interactions of quarks, electrons and photons. In that sense, symmetry is not decoration, it is the scaffolding of reality. But symmetries can also break. A pencil balanced on its tip has perfect rotational symmetry until it falls. Suddenly the symmetry is gone, and the pencil moves in a particular direction. In physics, such symmetry breaking explains why fundamental forces look different today than they did in the early universe. The weak nuclear force and the electromagnetic force, for instance, are two faces of the same interaction at high energies. As the universe cooled, the symmetry broke and the forces diverged. This is why symmetry breaking is so central to cosmology and particle physics. It accounts for how unity gives rise to diversity. Supersymmetry, which is often shortened to SUSY, S-U-S-Y, is a proposed extension of the Standard Model and pushes the idea of symmetry even further. It suggests that for every known particle there exists a heavier partner, a superpartner, linking matter particles, fermions, with force carriers, bosons. If true, supersymmetry would elegantly solve several puzzles, such as why the Higgs boson's mass is stable and whether dark matter could be explained by an undiscovered superparticle. For decades, SUSY has been one of the most mathematically beautiful candidates for physics beyond the Standard Model. It fits naturally with string theory. Yet, despite extensive searches at CERN, no superpartners have been found. Supersymmetry remains an enticing idea, but at present it is a symmetry awaiting evidence. Philosophically, symmetry resonates with our search for order and beauty. Many physicists, from Paul Dirac to Hermann Weyl, have believed that the deepest truths of nature must be expressed in symmetrical form. Sabine Hossenfelder has warned us not to take this too far. Beauty may mislead, but it remains true that symmetry has been an extraordinarily powerful guide. The concern with balance is not unique to physics. Eastern traditions, too, have long placed symmetry at the heart of their worldviews, though expressed in more symbolic forms. The Taoist yin-yang symbol, the Tai Chui, is perhaps the clearest example, a flowing symmetry where light contains a seed of dark and dark a seed of light. Originally rendered as the sunny and shady sides of a mountain, before becoming the circular symbol we know today, unlike a rigid mirror image, the symmetry is dynamic, emphasizing the interdependence of opposites. In Buddhist mandalas, symmetry is a tool for meditation, the balanced patterns representing wholeness and the structure of reality. Hindu yantras, with their intricate geometrical symmetries, serve a similar purpose, expressing cosmic principles when microcosm reflects macrocosm. The comparison is not exact. Physics finds symmetries in equations, while Eastern philosophy finds them in lived experience and cosmological imagination. But the resonance is striking. Both suggest that order is not accidental, that balance, recurrence, and relationality are woven into the structure of reality itself. For our wider discussion, symmetry raises intriguing questions. If the laws of physics are nothing more than the expression of symmetries, then perhaps the underlying reality is not made of stuff at all, but of relationships that remain invariant under change. Symmetry suggests that reality is defined less by what is present than by what remains constant when everything else shifts. That takes us back to the themes of emergence, relationality, and illusion that run through both physics and philosophy. So symmetry is more than aesthetic. It is a principle of survival, order, and law. The fact that the same rules apply, whether here or there, now or then, is what makes science possible. Without symmetry, the universe would be chaos. With it, we find the possibility of pattern, perhaps even the possibility of meaning. The laws of physics may not come first, the symmetries behind them might. Reality is less about things and more about relationships that remain unchanged as everything else transforms. Which means the problem isn't just whether the universe is made of, what the universe is made of. It might be whether permanence exists anywhere except in patterns. Are we living in a universe of objects or a universe of symmetry? Okay, next up we're on chapter 4, Mathematics, Beauty and Limits, and we'll come to section 32, Art and the Shape of Perception.